In this problem, Farmer Bob has 2,400 feet of fence, and he wants to build a rectangular enclosure that has a vertical partition. So he has 2,400 feet of fence, and he's trying to build a rectangular enclosure that has a vertical partition. So we begin by defining after making the sketch, we define some variables. Let's let x be the length of the enclosure, and let y be the width of the enclosure. Then the area is equal to x times y, and we would like to maximize the area. So to find the maximum value of a function, we'll find the critical numbers of the function, but the problem here is that our function, area function, has two variables, and that's a problem that has to be overcome, and we can do that with our material constraint here. The farmer has 2,400 feet, and that means that our two variables, x and y, are related in the following way. 2x plus 3y is the total amount of material used in this diagram. That should be all of his material, all 2,400 feet of fence. And therefore, we can see that the y variable is equal to 2,400 minus 2x, quantity divided by 3. And therefore, our area can now be written just in terms of x. Instead of being x times y, it's going to be x times this quantity here. So x times the quantity 2,400 minus 2x all divided by 3. And let's simplify that a little bit. So area is equal to, distribute the x, and we'll divide by 3. So 2,400 divided by 3 is 800. X, and then minus 2 divided by 3 is 2/3. And then x squared. So here is our area function now. It's just a nice simple function of x, and we want to find the maximum. So the maximum will happen when the derivative is 0. Let's have a look. The graph of this function, if I draw the x-axis here and the a-axis here, this is a quadratic equation, a quadratic function here. And so the graph is a parabola. The coefficient of x squared is negative 2/3. In particular, it's negative. So this parabola opens down, and clearly when x is 0, the area will be 0, so it goes through the origin. The graph looks something like this. And the maximum occurs when the derivative is 0. So we want to set up the equation a prime equals 0 and solve it for x. So a prime is easy. A prime is 800 minus, bring down the 2 here, 2 times 2/3 will make 4/3 times x to the first. So a prime is 800 minus 4/3 x. And we want to set that equal to 0, and now we have a linear equation. We solve for x. This means that 4/3 x is equal to 800, so x is equal to, well, 4x is equal to 2,400, and so x is equal to 600 feet, and that will give us the answer to our problem. The x coordinate where this maximum happens is x equals 600. And to give a complete answer, we also want to say what y is equal to, so we can come back up here. So y is going to equal 2,400 minus 2x, and x was 600, so 2x is 1,200, and divided by 3, and we calculate this, it's 1,200 in the numerator, divided by 3, and 12 divided by 3 is 4, so it is 400 feet. So y should equal 400 feet. So the best dimensions, the best dimensions are 600 feet here and 400 feet here. And that should use all of the fence. Let's double check. 600 here and 600 here makes 1,200, and 4, 4, 4 makes 1,200. And that's interesting. Half of the fence is used in the horizontal building of the structure, and the other 1,200, the other half of the material, 1,200, is used in the vertical construction. Okay, and finally, we could also answer what is the maximum possible area. So the max area is equal to, we take the x that we just found, which is 600, and we multiply it by the y, which is 400. And 6 times 4 is 24, and then we'll have 4 zeros. And that number is 240,000, and that's feet times feet. So that's square feet, a unit of area. So that's the maximum area. And that solves the problem.